It's time once again to learn on arguably the best subject in the world. Now, we've been looking at number bases for quite some time. We have been able to establish what number base is, right? We have also been able to look at the conditions that are necessary for um, converting one base to another. So today, this is what we are going to do. We are going to look at how we are going to convert from base 10 to other bases. We'll look at how we can add numbers in other bases, which is not base 10, and how we can subtract numbers also in other bases not in base 10. Then a quick one also to all of this is this. We're just going to use one questions to be able to explain all of these three things. And at the end of the day, note this. That would not be the end of the topic number basis. So subsequent classes, that's beginning from tomorrow, we will then look at how to solve questions that can be very tricky on number basis. That's for WAEC students and also for those who are preparing for JAM exams. So now let's get first one we have here. It says convert 85 base 10 to base 3. If you recall, when we're converting from other bases to base 10, what we did was we were multiplying. Now, if we're now converting from base 10 to other bases, what do? We'll do the opposite, which is now division. Very simple. So in that case, this is now going to be that we have here 85 and we are dividing by 3 because that's the base we are converting it to. So 3 in 8, what would that give us? That would give us that this is going to be 2, remainder 2. 3 in 25, we are going to have 8 rather, remainder 1. So note, our major concern is not necessarily what we have here. Our major concern will be our remainder. So that's where our mind should be stationed more. However, that does not mean we have to make mistakes here. Now, 3 in 28, that will be 9, remainder 1. If 3 goes in 9, that will be 3, remainder 0, because there will be no remainder. 3 in 3 is 1, also remainder 0. Now, when 3 goes in 1, that's not possible, so that will be 0, remainder 1. So we'll put our arrow up like this, taking it from the last number we have here, which is 1, 0, 0, 1, 1, base 3. And that's the answer on this. So we've been able to look at how to convert from base 10 to other bases. So now let's look at addition of number bases. Let's see how it is being done. Now the second one here, addition of number bases. We're asked to add 1, 2, A, 3 is 12. Remember, just remember this thing, more or less like a quantitative reason that your A is 10, B is 11, C is 12. Just remember those things like that. So 1, 2, A, 3 base 12 and 904A base 12. So now let's start. This is going to be 1, 2, A, 3. And then this is going to be A, 4, 0, 9. All in base 12. Now, before we start addition, we should have something at the back of our mind. Our numbers should range from 0 to 11. In this case, 11 in this case is going to be B, right? Should range from 0 to 11. So 11 should be the highest number we should have. We should not have C. Now, so let's also write this somewhere here, that A is 10, B is 11, C is 12, D is 13, E also is 14, and F is 15. So let's have this now. 3 plus A, what's A? A is 10. So 3 plus A is what? 3 plus A is 13. Now, if 3 plus A is 13, you can see that 13 obviously is bigger than 12. So since 13 is bigger than 12, I cannot write 13 here. Although if this was made, let's say base 14, instead of me to write 13, I would have easily had written B. That's letter D indicating 13. But 13 is actually higher than the range. So the range should have stopped at where? At 11, which is represented as what? B. If that be the case, since I have 13, anytime you have such a thing, what you do is divide it by the base. 13 divided by 12, I should be having 1, remainder 1. So I write down the remainder and take this one over here. That's how it's been done. 1 plus A, that's 1 plus 10, 11. 11 plus 4. 11 plus 4 is going to give us 15. We'll divide it again. So 15 divided by 12, we'll have 1 remainder 3. I write down the remainder 3 and I put 1 over here. 1 plus 2 is going to give us what? 3. Then 1 plus 9, that is 10. is within that range. But what is 10? 10 is A. So my answer is A331 base 12. And that's the answer, A331 base 12. So we are going to look at the last thing here, which is going to be subtraction of number bases. The very last question we are going to look at is subtract 1204 base 5 from 21013 base 5. How do we go with this? Very simple. So now note, we are taking away this from this, so meaning that this is going to come first. So we have here 21013 is 5, and then we have 4021 base 5. Let me quickly tell us this also. Let's take our mind back to very elementary mathematics. If you had something like 413 minus 38, I'll say 3 minus 8, you say it cannot go, right? You say you borrow 1 from here, it becomes 0. You add 1 to 3, it becomes 13. Have you ever wondered how true that is and how irrational it sounds? That's one of the craziest things I grew up with, and later asked myself, how irrational can this be? How do you borrow 1 from here and you add 1 to 3? 3 becomes 13. Like, how do you add 1 to 3 and 3 becomes 13? It's crazy. You cannot add 1 to 3 to become 13. So what should you have added? You actually added 10. But if you were told that you added 10 to make this 13, you would have been confused that why are we adding 10? But in actual sense, what we are just writing at the top is 1. So the truth is you actually borrowed 10. Yes. So that is why you say, I borrowed 1. Because anytime you check it out, anytime you borrow, it is 10 that is being added to that figure. Now, why it is 10 is because it is in base 10. Right? So we were not told that that was in base 10. We were just told that we're adding numbers and subtracting numbers, as the case may be. So indeed, it therefore means that anytime you borrow, what you are borrowing is that base and you are adding it to the next digit. Why am I saying that? 3 minus 4, it's impossible, right? So you are borrowing from this becomes 0, and you are adding 5. Note what I said. You are adding 5. That's the base. You're adding 5 to 3. So 5 plus 3 will give us what? 8. 8 minus 4 will be 4. It's 5. 0 minus 0 is 0. 0 minus 2 is not possible. We'll come over here again. We'll borrow from this guy. Here becomes 0. So what we have borrowed is actually what? 5. 5 minus 2 give us 3. We'll borrow from here again. Here becomes 1 and here becomes 5. 5 minus 1, 4. And then we are left with 1. And this is our answer, 14304. Sometimes I see students get confused with this subtraction. Wait, if you can understand this clearly, then you should understand this also. But you just need you to put your mind into it and you will learn it. It's as simple as it is. So we have come to the end of today's class. I want to plead with us. Go back and study. That's what I usually say. Just go back and study. If you have questions, you can send it to me directly or you put it on the comment section. Whichever way you do, once I get your message, I'll respond to it. So tomorrow's class, what we are going to look at is we are going to look at multiplication and division, right here. So when we are done with multiplication and division, then the next thing we'll do is we'll try to see how why it can be very funny with the way they will structure their questions for students. We'll look at that also, and that for JAMB students. And that would conclude everything on number basis. So thank you for following today's class. You have a nice day. Bless you.